So previous class just only history discussed. Just history, previous class. So what is Java? JDK first version 1.0. Yes, these are main features of Java. Okay, next version JDK 1.1 in the year 1996. In JDK 1.1, Java divided into 3 editions. Next JDK 1.2, next 1.3. Yes, next 1.4, 1.5, like this, different versions here. 1.5 Tiger version. Major changes were done in this version here. Many features added here. Yes, fourth edition called Java FX. Java FX added to JDK 1.5. So finally Java got the success with JDK 1.5. By the year 2010, most of the existing projects were converted into Java here. Yes, existing projects. Yes, developed in C, C++, Visual, VC++, Visual Basic, and .NET, SCPRP projects. These were converted to Java by the year 2010. Okay, most of the projects were converted. 2010 year, Oracle Corporation. Yes, Oracle Corporation has taken over Sunsoft. Now Java with Oracle Corporation. So next JDK 1.6, like this, all that features. We'll see all that features. Yes, by after finishing your course. So finally, Java divided into 4 editions. See, initially in JDK 1.1, Java divided into 3 editions. Yes, in 1.5, one more edition, 4th edition added, called as FX. So finally, Java divided into 4 editions. Yes, first one Java Standard Edition. It's a Java technology. Next, Java Enterprise, it's application development. Java Standard Edition, Java Enterprise. Okay. Yes, only these two editions are using. These are not using. Java is poor in this area, not using. Java Standard Edition. Java Standard Edition, their features. Yes, our syllabus. Yes, Java SE. This is our syllabus features. Like they are not different features. In previous class discussed. Just the core part of Java means compiler part. Core part means compiler part. Next Java features. Next other features. So last class discussed all of these things here. Networking, multi-threading. Okay. Yes. So up to multi-threading is our syllabus. After finishing complete syllabus, finally version-wise features. Version-wise features up to 13 version, Java 13. Next, other features. These are other features. JDBC is a part of Advanced Java. Is not a part of our syllabus. Next, AWT applets also there, but these were outdated 15 years ago. No one using. Okay, next intervention. Yes, all the frameworks comes under intervention. Frameworks like Spring Framework, Hibernate. This is Java application development area. Next, this is big data area. Okay, so big data area. How do you construct? It's a big data area. Yes, Struts framework also for the Java application development, but outdated. This is outdated. Okay. Yes, after finishing your course, after finishing the core Java, after finishing your core Java, Java transition, you have to decide whether to become Java developer or big data developer or yes, testing Selenium developer here. So big data developer. Yes. Suppose after finishing your course, if you want to become Java developer, you should learn these frameworks. So big data developer, you should go for these frameworks here. Okay. Suppose if testing Selenium, yes, directly you can start. Yes, after finishing core Java, you can go to testing Selenium or data science. Any of these things you can choose. So these things we discussed in previous class. Okay. Now let us start with Java features. Let us start with Java features. These are features of Java. These are features. These are all the features. They are the main features of Java. Let us see one by one all the features here. Yes, one second. This guy is struggling to join. 1 second. Just 1 second. This guy is struggling to join. Yes. Here, they are the main features of Java. Here are main features. Main features of Java. They are main features of Java. These are main features. So in this independent of platform, portability, OOPS language, scalability, and security. These are the main features of Java. Let us see one by one. So what is independent of platform? How Java made us independent platform? Yes, what is portability? How Java is portable? Yes, what are the OOPS features? What are the OOPS features implementing in Java? So these things we'll discuss one by one. Okay. Yes, to understand these features here, first of all, you must have some some basics knowledge. To understand all these features here, you must have some knowledge, basic knowledge like about operating system. So what is operating system? Yes, about operating system knowledge, how OS is working, about OS knowledge. Okay, independent platform means OS. How Java made us independent platform. To understand this, you must have knowledge of OS architecture. Yes, I will explain how OS is working internally. Internally, how OS is working, I'll explain very clearly. After that, I'll go to this independent platform. Don't worry. I'll explain that basics also. So next here about exe file on dot class file requires. So what is exe file? C language exe file. C language exe file is OS dependent. In Java, it's a dot class file. Dot class file is independent of platform. Yes, how that comparison? That comparison. So once exe file idea, dot class, once you got this idea, then you can understand independent of platform. So first OS knowledge, next exe file knowledge, dot class file knowledge. Yes, after that here, next interpreter knowledge. Interpreter, how interpreter working? Okay. Yes, interpreter and compiler knowledge. Yes, interpreter and compiler. Interpreter and compiler. Interpreter and compiler. How compile is working, interpreter is working. If you have that knowledge, you can understand very clearly. Okay. Yes, interpreter and compiler. Java depending on both interpreter and compiler. Okay. Yes. So for that reason, you must have interpreter knowledge. Yes. Compile knowledge. Yes, interpret knowledge and compile knowledge. Suppose C language, purely it's a compiler. The C language purely it's a compiler. Okay, 1 second, 1 second. Just 1 minute. Yeah, to understand all of these things, that minimum knowledge. What is base? What is exe file? What is dot class file? Next, what is interpreter? What is compiler? Next, generation of language. What are the generation of language? Generation of language. Yes. If you have this knowledge, then you can understand all the features very clearly. So let us start with this. Let us start with this. Okay. So let us start with all of these things. So what is OS? What is exe file? What is dot class file? What is interpreter compiler? So what is generation of language? All of these things. Yes, all of these things. So all of these things. Yes, all of these things we'll discuss one by one. Okay. Now okay, let us start. Yes, OS. So before going to AS, yes, let us start from basics. Yes, I'm starting from basics. Everyone can understand. Okay, even non-IT background guys also can understand these basics here. Yes, you must have this knowledge basics of software. So once you have the basics of software, then easy to understand next coming topics. Okay, so before going to Java, there are some basics. Okay, we'll see about basics. Yeah, the basics like see. So basics like what is software, what is system software, what is application software. Next, what is OS? Okay, simple basics here. So after that, next in application software is a front end back end. What is front end back end? Next, language and packages. About languages, low level languages, high level languages. These things. Next generation of languages. So these concepts. Next, after this, next. Yes, about interpreter and compiler. The differences interpreter and compiler. Okay. Yes, after that, Java. Java depending on both interpreter and compiler, how it is, that reasons. So once you understand all of these things, next we can understand. You can understand these features very clearly. Okay. So for that, yes. So you can understand all this exe file, dot class file, all the concepts here. So all the concepts prepared very clearly in documents here. You can follow documents here. You can follow the documents here. In document, everything very clearly prepared. So here running notes is not necessary. Running notes is not necessary. Very clearly prepared. Try to follow just you try to follow documents. Let us start from the basics here. Okay. Simple here. Everyone can understand this one very clearly. See computer where. See computer where, right? Computer where means computer field. Okay. Computer where. Computer field. Yes, computer where basically two categories. First one, yes, hardware. Second one, software. First one, hardware. Next one, software. So hardware means these are physical components of a computer. These are physical components of a computer like keyboard, mouse, monitor, hard disk. All this comes on hardware. We can touch all these parts. Okay, but not required for us. Yes, our topic is software. We are the software engineers. So we are the software. So let us start with software. So what is a software here? Let us start with software. Okay. So till yesterday, all that just only Java overview completed. Today actual classes started. Today actual topic started. Today actual topic started. Till yesterday, last two classes, just Java overview completed. Today actual classes. Okay. So from the beginning, from the basics started. So software, what is software? Yes, software in software. Yes, everything is a program. In software, everything is a program. Yes, in software, everything is a program. In software, everything is a program. Okay. Yes, it is a collection. It's a collection of programs. Simply can say collection of programs like C, yes, C++, Java, yes, like this, different programs, all the programs. Okay. Next here, software. Here the software basically two categories. Software basically two categories. Software basically two categories. Two categories. Software basically two categories. First one, yes, system software. First one, system software. Second one, application software. Second one, application software. System software. Next, application software. Okay. So first one, system software. Next one, application software. Okay. Software basically two categories. First one, system software. Next one, application software. So first one, system software. So what is system software? System software. System software. This one interact with hardware components. System software. Yes, it interacts. Interacts with the hardware components. Hardware components. Interacting with hardware components. Interacting with hardware components. Okay. So system software, it interacts with hardware components. Okay. System software, this one interacts with hardware components. For example here, for example, Yes, operating systems and device drivers. Operating systems and device drivers. So system software, it interacts with hardware components. Example, operating systems and device drivers comes on this category. So next, application software. What is application software? Yes, yes. What is application software? Application software. This is for the purpose of application development. 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 Applications apps. Yet there are different apps we are using daily life. In our daily life, many applications we are using. Yes, guys. Can you tell me some examples? What are the applications we are using daily life? In our day-to-day life, we are using many applications. Yes, can you give me some examples of applications? Yes, you working some applications, right? You can ping in chat box. Need not speak. If you are unable to speak, you can ping in chat box. Here chat box available. You can ping in chat box. See, tell me. So what are the applications? Yes, using in our daily life. Tell me. Yes, every day using some applications. What are the applications? Any idea? What are the applications using in our daily life? So what are the applications? No idea? Yes, what are the applications? Yes, simple. Yes, Facebook is application, right? Now tell me. Facebook is application. Sharing your information. Facebook to share your information, that's it. Next, any others? Facebook. Next. Facebook is an example of applications. Next, what? WhatsApp. Yes, WhatsApp. WhatsApp is an application. Chatting application. Okay. Next, Twitter for tweets. Twitter is an application. Next, Flipkart, online shopping application. Next, suppose company websites, like different kind of things are applications. Okay, e-commerce applications, online shopping applications. Even go to training app, go to meeting app, Zoom meeting app. Yes, all the apps. These are the apps here. Next, banking applications. Next, stock exchange applications. Yes, in our daily life, we are using many applications. Food delivery apps, all are the apps. Okay, so how to develop such kind of applications? How can you develop such kind of applications here? For this, we need some application softwares. To develop such kind of applications, we need some softwares. Those are called as application softwares. To develop to develop this kind of applications, we need some software. Those are called as application softwares. Example application software. Best example Java. Java is the most used application software. See, in market existing applications, 80% of existing applications were developed in Java only here. 80% of application developed in Java only here. Yes, even go to training app developed in Java. Go to meeting app. Next, Flipkart in Java here. Facebook in Java. WhatsApp also in Java. Twitter also in Java. Yes, most of the websites in Java. Online shopping applications in Java. Okay, 80% of existing applications developed in Java is a mostly used application software. Java. Next, Python. Python is application software. Next, Hadoop is application software. Next, databases are application softwares like this. There are different application softwares. Okay. Yes, not only here. See, in software we have the many softwares are there. Maybe a lot of confusion. Which is application software? Which is system software? Exactly here. Maybe confusion. System software, no confusion. In case of system software, no confusion. Okay. So you are interacting with hardware components. So OS and device types. Only these two things comes on system software. Only these two things. So voice on device driver systems, voice interacting with hardware. Voice can talk to hardware. Device driver to run the devices. So their system software is okay. Yes, when come to software field, we are using many technologies, many things like Java, Python, HTML, next C language, C++, Hadoop, databases, some reporting tools, testing tools, infrastructure management tools, many kind of things using here. What are these things? Let us see. Languages, languages like Java language, Java, Python, C, C++, HTML, Perl scripting, PHP, like this many languages. Scala, like that many languages. Okay, next languages. Next tools. There are some tools. Some tools using here, like tools like yes, cloud infrastructure management tools like AWS tools, DevOps tools, AWS DevOps tools. Next, testing tools like Selenium tool, QTP tool, some testing tools. Okay. Yes. Next, some reporting tools like ClickView and Tableau, like these tools, languages and tools. Next, some packages. So packages. So package means the ready-made one, ready to use. For example, ERP packages. So SAP ERP, Oracle ERP, Tally ERP. Next, yes, MS Office, all the packages. Okay, languages, tools, and packages. Language, tools, and packages. Yes, all of these things comes from application software only here. See, except ways. See, except, except operating systems, except operating systems, except operating systems, except operating systems. All are all are application softwares. All are application softwares. All are application softwares. Yes, simple this is. Now its confusion is clear. Okay. See here, many softwares we are using. Yes, many software field, many softwares are there. Many things are there. Oh yes, hundreds of softwares are there, hundreds of technologies. Okay, yes, in this except OS. OS interacting with the hardware components. So OS comes from system software. So OS interacting with hardware components. So OS interacting with the hardware components. So OS comes on the system software. See, except that OS, except OS, except OS, all are application softwares. All our application software simply can remember like this, except ways all our application softwares. Okay, yes, Java comes under application software. So this is our topic is Java application software. So before going to this application software, let us see something about OS. Yes, to understand Java features, about OS knowledge, understanding Java features like independent platform. To understand independent platform, first of all, you must have OS knowledge. So let us see about OS knowledge here. About OS. So what is OS? About OS. About OS. Let us see about OS. About OS. See, OS. About OS. See here some question for you guys. Here's some question. Question is, question is, can we run, can we run, can we run any program? Any program? Yes, without voice. That's a question. Without voice. Can we run any program without voice? That's a question. Simple question. Yes, come on. Try to answer this question. It's very simple question. Can we run any program without voice? Say yes or no. Yes, chat box is there. You can ping in chat box. Yes, come on, guys. Can we run any program without voice? Say yes or no. Yes, you can ping in chat box. Check your chat box. In chat box, you can ping answer. Please don't keep quiet here. Try to respond. Yes, even answer known someone is not responding. Please try to respond. Generally, my class are interactive classes. My classes are interactive classes. Okay. Yes. Hi. Yes. You should ask questions. I should answer. Next, I should ask questions and you should answer. So vice versa. Vice versa. Yes. So can we run any program without voice? That's a question. Can we run any program without voice? Yes. Answer. Answer is no. Answer is no. Yes. Can we run any program without voice? Answer is no. Without voice, we can't run. We need voice. Then what is hypertext? Let's see. What is hypertext? So what is hypertext? Let us see. Without voice, we can't do anything. So voice required compulsory. If no voice, no computer. No voice, no computer. Okay. Suppose, for example, here, yes, laptop. Suppose you purchase some laptop. Yes, your hardware. Yes, hardware. Yes, once you purchase the hardware laptop here, that laptop vendor, yes, with OS, they will provide us. Yes, they will give the laptop with OS, including OS. Okay, so they will set up OS operating on top of hardware OS setup. Okay, so once OS setup is done, our system is ready. See, this is my system with OS. This is my computer with OS. Okay, yes, now this OS, Windows OS. Now this OS is responsible, yes, to run any request here. Suppose when I click on some Eclipse, OS is responsible to launch the Eclipse. Suppose when I click on WhatsApp, OS is responsible to launch the WhatsApp. So Putty tool. When I click on this, OS is responsible. Suppose WinSAP. So OS is responsible. So for every request, OS is responsible. For every request, OS is responsible. Okay, right? So what's happening here? See here. So without OS, no computer. So once OS started, our system is ready. Once OS setup is done, our system is ready. Suppose learning C language. For this, you have to install C software. Learning C++. For this, you have to install C++. Suppose learning Java. Java should be installed. Suppose learning Hadoop. That Hadoop should be installed on top of OS. Suppose using database. The database should be installed on top of OS. Yes, all these are called as application softwares. All these are called as application. All these are called as application softwares. All their application softwares. Application softwares. So these application softwares all are running on top of OS. Okay, on top of OS, all are running C, or C++, Java, Hadoop, all are running. See, all are running on top of OS. So that means OS is giving platform. Just OS giving platform. Yes, OS giving platform on top of OS. On top of OS, all are running. So it's giving platform. So OS giving platform to run all the programs. That means it's acting like a platform. So what is OS? What is OS means? Simple answer here. What is OS? So what is operating system? Okay. For the simple answer, what is OS? It's a platform. Yes, it is a platform. So OS is a platform. It's a platform. It's a platform. OS is a platform. Yes, it's a platform. So what is operating system? It's a platform. Yes, where we can run. Yes, OS is a platform where we can run all the application softwares, all the application softwares, all the application softwares. That's it here. All the application software. Okay, these are our application softwares. These running on top of OS. So like a platform. So OS is a platform. So OS is a platform where we can run all the application software. Okay. See here Java. So Java is independent of platform. Platform is what OS. Platform means OS. Yes, Java is independent of platform. It's independent of OS. How is Java made as independent of platform? We'll discuss. Wait, I'll explain. Okay. Yes. So what is OS? It's a platform where we can run all the application software. See, not only acting like a platform, not only acting like a platform. Suppose these application software programs, maybe Java program, maybe C program, delivering some output, delivering some output. So output of all these programs simply goes to OS. First of all, deliver to OS. First of all, deliver to operating system, and then transfer to output device. Next, transfer to output device. Okay, so all these application softwares output That output delivers to OS first of all. From that transfer to output device. Okay. Here there is no communication between stick here. No direct communication. Yes, applications of never interact with hardware components. No direct communication. So never happens like this. No direct communication. Okay. Suppose reading data from the keyboard. Reading data from the keyboard. Reading data from the keyboard. So first of all, keyboard data goes to voice. Keyboard data goes to voice. Voice to application softwares. Okay. So keyboard data goes to voice here. Voice to next application softwares. So between application software and hardware, there is a voice like a mediator. It's a middle layer. So between application software layer, hardware layer, this is a voice layer. So like a mediator means exactly you can call it interface. So right terminology interface. So voice acting as interface between application software and hardware components. That's it here. So next point. So what is voice means? Yes, it's an interface. It's an interface. It's an interface. It's an interface between 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 applications of yes, it's an interface between this application software under under this layer, hardware components layer, and hardware components and hardware components. Okay, yes. Next, one more here. Yes, in every ways there is a library. In every ways there is a library here. So what is library here? Library is a collection of functions, input output functions. Library is a collection of input output functions. Library is a collection of input output functions. See, operating systems like Unix based, Linux based, Windows based, all these operating systems were developed in C language. These operating systems were developed in C language means here library means C language functions. It's a C language functions. Okay, C language functions. For example, here C language library, stdio data header file is a C language library. That stdio data header file can is what here? stdio data header file. It can standard input output related functions here like printf scanner. Same exactly here. Library. It contains all C language functions. C language functions. Library is a collection of functions. Library is a collection of functions. Okay. Yes. Now here. So every voice has its own library. Its own library to communicate between application software hardware components. So voice using library to communicate between application software hardware components. Okay. So this point is very important for us for the Java perspective. Java perspective, this point is important. Try to understand clearly. So every voice has its own. Every voice has its own libraries. Its own library. Yes, to communicate. Yes, to communicate between application software and hardware components. So every voice has its own library to communicate between application software and hardware components. Okay, fine. Next, one more point here. See, C program, Hot C++, Java, Hadoop, database, whatever this here. All the programs. First of all, linking with OS library. All these programs links with OS library. After linking, then it will communicate with the hardware components. So before going to run it, before going to run any program, that program has to link with OS library. It has to link with OS library. Okay, all the application softwares like C plus Java, all the programs has to link with OS library. After linking, then communicates with the hardware components. Okay, so every program, okay, yes, every program, see every program has to link with OS library. OS library has to link with OS library before going to run it. Before going to run here. Okay, every program has to link. Every program has to link. After linking to OS library, then execution starts. Yes, using OS. So here all the programs first of all linking with OS library. So first of all linking with OS library. After linking with OS library, then communicates with hardware components. That's it. It has to link. Yes, that link may be static link or dynamic link. Suppose if C and C++ is static link. Suppose Java and Python is a dynamic link. Okay, I'll explain what is static link, what is dynamic link. We'll discuss clearly. I'll explain practically. The topic also I'll explain very clearly here. Okay, yes. So every application software program has to link with Waze library to communicate with hardware components. So before going to run here, that should be linked with Waze library. After linking with Waze library, then execution starts. Okay, suppose C and C++ static linking. Static linking. Java and Python, it's a dynamic linking. Yes, I'll show that. Okay, so next topic. Today only I'll show that. What is static link? What is dynamic link? I'll explain very clearly. Okay, so these about ways. See, remember this point, last point. Remember this point here. Yes, independent of platform. To understand these features, this one requires. Last point. Every program has to link with Waze library before going to run here. Every program has to link. So every program has to link with Waze library before going to run. Every program has to link with Waze library before going to run. That may be static linking or dynamic linking. Yes, we'll discuss next. So this is about Waze. Just idea about Waze. Okay, so once you have this idea, then easy to understand independent of platform. So this is about Waze. Okay, fine. Let us go to document here. See in document, same introduction explained here. Started with introduction here. Software is a collection of programs such as C, C++, Java, SQL, and other programs. Software basically two categories: system software, next application software. System software, it interacts with hardware components. System software, it interacts with hardware components. Example, device drivers and operating systems. Application softwares, for the purpose of application development. For the purpose of application development. Example, C, Java, .NET, ERP, and others. Except ways, except operating systems, all are application softwares. Right? Okay. So system software. In this device drivers and ways. Device drivers, they run the devices, some devices. Okay. Next ways, same these points. Okay. It's a platform where we can run all the application software. It's an interface. Okay. See every program, yes, links with Waze library. Yes, yeah, I'll share. Don't worry. I'll share documents. Okay, documents, videos, everything I'll share it. Okay, all of these things I'll share it. Don't worry. So every program links with Waze library before going to start execution. Before going to start execution. Okay, same points explained here. See hardware. On top of hardware, this Waze. On top of Waze, this application software. These Waze. Okay. Yes, our topic is application software. Java comes under application software. Java is a application software. Java is a application software. So let us start with application software. See, application software. Let us move to application software. Yes, in application software. So basically two categories: front end, back end here. Application software, front end software, back end software. See what is front end, what is back end here. Front end, back end. So for example here, here providing some information, right? Some information like first name, last name, email address, and phone number. We are providing some information and registering. Yeah, this one is called as front end. It's a user interface. This is user interface. It's the interface given to you. Here you have to provide all this information. You have to provide this information and submit. This is called as front end. So this is called a front end collecting data from you. So front end always collecting data from users. After collecting data from end users, storing to some location. Same this data. So whatever you submitted this information, that information storing some location. Okay. So next day, Durgasoft, they will take all of your contact numbers, they will follow. Means your information storing somewhere. That location called as backend. Backend. So backend is a location where storing and maintaining your data. Backend is to store the data. Front end is collecting data. So this is called a front end here. So front end is to collect the data, collecting data from users. Backend is to store the data. See this. Yes, same thing explained here. So what is front end? What is back end? See this front end. Front end. Yes, these are to interact with end users. front end. These are to interact with end users. It collects data from end users and stores in backend. Collecting data from end users. Yes, backend. Yes, to store and maintain data. Backend to store and maintain data. So databases and files. Database and files comes in this category here. Okay. So front end, backends. Yes, Java comes under front end. Java is a front end. Java is a front end. Okay. Yes, Java program using form collecting data. So behind of job, this form, some JSP running. Behind of this form, this JSP. That JSP is Java program. That Java program collecting data from this form here. So Java is a front end. Okay, right? Yes. Right. So Java comes on the front end here. Front end. Next in front end, again there are two types: language and packages. Language and packages. Language and packages. Okay. So package is ready-made one. Yes, package is ready-made one, ready to use. For example, MS Office is a package. See home. Yes, insert menu, file menu. Like there are different menus: home menu, insert menu, design menu, layout menu. So predefined one, right? Yes, using predefined options, we can prepare one document. Yes, here no programming. No programming. Suppose ERPs like Tally ERP, SAP ERP, no programming. Simply forms. Fill the form, submit data. All that ERPs comes under package. So package is a ready-made one. Package is a ready-made one. Okay. Once again. Yes, about notes, you don't. Yes, you need not write notes here. This document for you only. This document I prepared for you only. I'll share this document. I'll share to everyone. Okay. Yeah, this is around 530-page document. 530-page document. Many programs are there, including programs and interview questions. Many things are there. This document for you only. Okay. Yes. So package is ready-made one, ready to use. Okay, ready to use. Language. In language, we should write some coding. We should write some programming. But the programmer has to write the code. So Java comes under language. Yes, let us go to language. Okay, Java is a language. Okay. Yes, see that. Yes, introduction. How I am introducing you to Java. That way of introducing. See, hardware and software. Java is a software. So start with software. Software two categories: system software, application software. Java is the application software. So move to application software. Mode. Okay, in this front end, back end. So Java comes on the front. So we moving to front end. Front end language and package language. Yes, now I'm moving to language. So Java languages. Okay, now let us see language. About languages. Yes, language. What is language? Yes, it's very simple. I think need not explain for you. So what is language? Language just it's a media of communication between two things, right? Language. See, what's a language? Language just it's a media of communication. Language is a media of communication between two living things. Two living things. Maybe two persons or two animals or two trees. Okay. Yes, just media of communication. One second, let me have some water. Yes, come to software. In software, see your computer understanding some language. See computer understanding some language. So computer understandable language. Computer understandable. So what is computer understandable language? Computer understandable language is it? Yes, binary code. It's a binary code. Yes, computer understandable language. Yes, is a binary code. Yes, computer understanding some language. That language, computer understandable language called as binary code. Binary code, it is in the format Juris ones format. Juris ones format. Juris ones format. It's a computer understandable language. Okay. Next, we are understanding some language. See, Binary code, this is not our language. It's a computer understandable language. We can't understand this binary code here. So for us, like different languages, like C language, C language looks like a yes English language. Suppose C language. This is C program. C program like English language, right? This is like English language. Okay. Suppose Java. Let us take some Java program. Suppose Java program. Java program. Yeah, this sounds like English language. Java program. Suppose Python. Python script. Yes, Python script. C Python. Right? See, all are like English language. So this is our language. Yes, we can understand this. This language can user understandable language. User understandable language like English language. User understandable. Okay, user understandable. So computer understandable. Next, second one, user understandable. Second one, user understandable. User understandable. User understandable. So computer understandable. First one, computer understandable language. Okay, second one, user understandable language. Yes, computer understandable language is low level language. User understandable is a high level language. In software, languages are two categories. Software languages are two categories. Languages are two categories. Languages are two categories. First one, yes, high level languages. Sorry, first one low level. First one low level languages. First one low level languages. First one low level languages. Second one high level language. High level languages. Low level language and high level language. Okay. See, low level language is a computer understandable language. It is system understandable language. Low level language. So what is low level language? Low level language, it's a system understandable language. Yes, it is a yes. Yes, it is a system understandable. It's a system understandable. It's system understandable. Low level language is a system understandable language. It's a system understandable language. Low level language is a system understandable language. Okay, system understandable language. System means is a processor. System means it's a processor. System means processor. It's a processor understandable language. Processor understandable language. Okay, so low level language, it's a system understandable language. Okay, it's a system understandable language. Yes, it is in the form of binary code. It is in the form binary code. Zeros ones format. Okay, it's in the form of binary code. Yes, it is called as machine language. 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 Okay, first one low level language. It's a system understandable language. System is a processor. Yes, it's in the form of binary code, zeros and ones formats. Yes, it is called as machine language. It is called as machine language. About low level language. Next, high level language. This is our language. Means user understandable language. So high level language, it's a user understandable language. High level language. Yes, it is a user understandable language. It's a user understandable language. Okay, high level language. It's a user understandable language. Yes, it is in the form of English language, right? See here. Yes, user understandable. This Java, user understandable. Java program. Yes, Python script, like English language. Yes, C program. Okay. Yes, all these like English language, right? Okay. Java, Python, yes, C program, all are like English language. Okay, right? Very easy to understand. Called as user understandable. C is a first high level language. Yes, the generation of language we'll discuss. Generation of language I'll explain. Yes, high level language, it's a user understandable language. Okay, right? Yes, it is like English language. It's like English language. It's like English language, like English language. It's like the English language. Yes, very easy to understand. So it's very easy to understand. Very easy to understand. It's very easy to understand here. Very easy to understand. So high level language. It's a user understandable language. It is like English language. It's very, yes, it is very easy to understand. Correct? Yes. So you can low level languages and high level languages. There are two categories of language: low level and high level languages. Okay, that's okay, fine. Now here, some question here, some question, some question. See, Java program, it's a high level language, but system executing this language. How? How? A system cannot understand this language. Suppose let us take Python scripting. Python scripting also like a English language. What system are executing? Yes, how it is. Okay. Yes, maybe Python scripting. Yes, maybe Java codes is like English language. English language. So this every English language, this high level language instruction has to convert into binary codes. Every high level language program, that English language program has to convert into binary codes. Means system understand format. Who will convert here? Okay, that high level language, high level, yes, high level language, converting, yes, converting into binary codes, converting into binary code here. So binary codes. After converting into binary code, yes, high level language converting into binary code. After converting into binary code, then running, getting result, right? Yes, who will convert? Who will convert from high level language to binary code, means low level language? Tell me any idea? Who will convert? Now, which one will convert? Which one will convert from high level language to low level language? Yes, case, any idea? High level language to low level language. Suppose C program. Yes, like a high level language, like English language. The C program will convert into binary code. Who will convert it? So Python script. Even Python script also has to convert into binary code. Who will convert it? Who will convert it? Who will convert it? Yes, who will convert? Yes, either compiler or interpreter. High level language converting to binary codes. Either interpreter, yes, either interpreter, or compiler. Either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler converts from, yes, high level language. Converts from, yes, high level language. Converts from high level language to binary codes. The system understandable language. High level language is system understandable binary codes. Either interpreter or compiler converts. So either interpreter or compiler converts from high level language to binary codes. So what is interpreter? What is compiler? This is most important topic. Every software engineer must have this knowledge. So what is interpreter? What is compiler? It's Java. See, Java independent of platform. To understand independent of platform, you must have this interpreter and compiler knowledge. Java is independent of platform and portability. To understand that features here, you must have this knowledge. Interpreter and compiler. Now let us see about interpreter and compiler. So what is, yes, interpreter, compiler. Interpreter versus compiler. Yes, interpreter versus compiler. So what is interpreter? What is compiler? Yes, any idea? Any idea? Yes. So interpreter. For interpreter purpose, I'm taking Python script. For compiler purpose, I'm taking C program. Let us see the difference. C compiler, how it's working. Python interpreter, how it's working. Let us see interpreter and compiler. Okay. Yes, Python script. See my system D drive. In D drive, here they say mn Python. Here they say test.py script is available. The Python script is available. One second. Here Python script is available. See, cmd command prompt, go to command prompt. Yes. So D drive mn Python. So D drive, D column will take to D drive. Yes, DR output here. See this. MN Raw Python directly. So CD, yes, MN Raw Python. Yes, MN Raw Python. MN Raw Python. See that. Right here, some output. Okay. Yes, here test.py file. Yes, Python script. Notepad, test.py. Yes, so fine. The Python script. Yes, how Python script is working. C equal 10. B Python is the interpreter based language. Python is the interpreter based language. Now our topic is about interpreter. Okay. So A equal 10, B equal 20, C equal to A plus B. Adding this to here. Yes. Constant is displaying C value. Next C equal to A minus subtraction. C equal to A and B multiplication. Okay. Save and run it. Save and run it. Okay. Run it. Java C. Java C test.py. Okay. Sorry. Not Java C. Python. It's a Python. See. Execute it. Directly execute it. Suppose if it is C program, first of all checking for all errors. If it is C program, first of all checking for errors. If no errors, executing it. But not this case. Python case, no errors checking, nothing, directly executing. Python script executing directly here. Suppose some errors, what happens? In Python script, some errors here. Suppose let us make here error, some mistake here. Okay. Suppose here some mistake. Suppose here some mistake. There are three mistakes in this script. There are three mistakes here. No compile. Yes, now run it here. Run it. Yes, Python test.py. See this. It's 7th line error message. So what's happened here? What's happened simply here? So that yes, Python interpreter checking for the first line. Yes, correct. Statement is correct. It executes. Means memory allocating for a storing 10. Next checking for this B equal to this also correct. It allocates memory for B and storing 20. Memory allocating for a storing 10. Memory executed this statement, executed this statement correct, executed this statement correct, executed this statement correct, executed. After that, print addition equal to yes here error message. Once error comes, simply stop. So you get this statement correct, immediately executed, correct execution, checking syntax and execution, checking then execution, checking then execution, checking execution here. Okay, suppose any error coming, simply stopping there. That's it. So once error comes, interpreter starts. It won't go for next coming statements. Okay, it won't check for next coming statements. Once error comes, simply stopping here. So interpreter shows only one error. Interpreter is only one error here. So once any error comes, simply stopping. So once error comes, interpreter stops. So interpreter shows only one error. Interpreter shows only one error. Interpreter is only one error. Interpreter is only one error. Okay, now see that. Interpreter only one error. See that. This error. Next error is not displayed. Next error is not. Actually, there are three errors. Only first error displayed. Okay. Yes. Now correct this mistake, comma. Save. See this. Yes, again this error message. Subtraction equal here. This is error. End of line scanning. String literal means the W literal means W quotation. The W quotation is missing. So next only one error, right? Yes, again only one error. 7th line error correction is done. Next line error. So only one error at a time. At a time only one error here. Only one error. Okay. Yes. Only one error. See this. So next this is save. After save. Now yes, run it here. Python. Yes, one more error. 70th line error. 70. Yes, one more error. Like this, only one error. It won't show all the errors. Suppose if it's C compiler, what happens? It shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Now see this here. Yes, no errors executed. Top to bottom execute. That's here. This is working of interpreter. Okay. Yes, let me explain Word document here. First about interpreter. Interpreters. Suppose source from source code. Interpreter source code. interpreter, source code. Source code about test.py, Python script. Okay. Yes. Suppose there are some statements here. See, Python script. First statement. Next statement. Yes, next statement. Yes, next statement. There are some statements in Python script. There are some statements here. In Python script, there are some statements. So next statement. So next statement. There are some statements. In Python script, there are some statements. Maybe Python script or any interpreter-based language. Yes, we have many interpreter-based languages. There are many interpreter-based languages. Okay. Python is one example. Python, HTML, Linux, shell scripting, like this. There are many interpreter-based languages. So in all of these things, how interpreter is working here. So interpreter checks for the first statement. Suppose first statement is correct. First statement is correct. First statement is correct. That statement simply converts into binary code. Just converting to binary like a zeros ones format. Yes, here first statement is correct. So once the first statement is correct here, the statement converts into binary code. After converting it to binary code here the statement given to processor. So processor taking this statement and generating outputs. Generating outputs. Okay. So interpreter checking for the first statement. If first statement is correct, that converts into binary code, converting into binary code and given to processor. So processor will run and giving results. See, next coming statements will be right or wrong. So interpreter never think about next coming statements. Interpreter never think about next statements here. Yes, if statement is correct, immediately executing and generating output. Suppose checking for next statements. After this, checking for next statement. Suppose next statement also correct. Suppose next statement also correct. Same conversion zeros ones formats. Okay, and submit to processor here. So correction then execution. Yeah, checking syntax then execution. Checking syntax then execution here. Interpreter first line checking then execution. Second line checking then execution. So line by line. So first line checking then executed over. Second line checked correct executed. Third line something wrong here stopping. Something wrong stopping here. Something error stopping here only. That's it. Something wrong stopping. Something wrong stopping here. Any error can simply stops here. That's it. Okay. So what happens here? Interpreter line by line. First line checking, then execution immediately. Second line checking, then executing immediately. Suppose any error comes, simply stopping there. That's it. It shows only one error. It won't go to next statements. Once error comes, simply stopping there. It won't go to next statements. Okay. Yeah, that I showed practical. Just now showed practically. So this is working of interpreter here. Yes, how compiler working for the same program? Yes, compiler. How compiler working here? For compiler purpose, let us take some C language. C is a compiler based. C is a compiler based. Let us take C language, compiler based. Yes, C is a compiler based. C is a compiler based. Compiler based. Okay, source code. Support test.c. C program. Test.c. C program. Yes, let me start Linux for the C program. Yes, here how it's working here. Test.c program. Yes, how it's working. Test.c. How this test.c program is working. Like let us see about C program here. How it's working. How this is working. Let us see. Yes, if it is compiler, what happens here? Compiler checking for the first statements. If first statement is correct, even it's correct, it won't convert into binary code. No. Checking for next statement also. Suppose next statement also correct. It won't convert into binary code. Next checking for next. Suppose something wrong here. It shows error at some line. Error at third line. After that, checking for next statement. Suppose next statement is correct. Simply go to next statement. Checking for next one. Suppose next one also correct. Go to next statements. Next one also correct. Next statement. Suppose something wrong here. Error at some line here. Error at some line. Okay. So checking for next statements. Checking for next statements. Checking for next statement. Suppose here something wrong. So you can checking from top to bottom. Compiler checks the whole code from top to bottom and shows all the errors. Compiler checks whole code from top to bottom. Interpreter is line by line. First line checking, next line checking. Any error comes should be stopping. Interpreter stopping. But compiler is not like that. It checks whole program from top to bottom, and shows all the errors. Shows all the errors. Let us see that. Yes, how compile is working here. Yes, it shows all the errors. Now correct all the errors. Correction. Next you have to correct. As a programmer, you have to correct here. After correction, recompilation. Suppose next time, no error. Here also no error. Next time, here also no error. Everything is fine. If everything is fine, then compiler it opens another file here. Okay, this is our test.c file. Test.c means source code file. A test.c is a source code. Source code means your program file called source code. Okay, now, yes, if no errors in the whole program, we are checking all these statements from top to bottom. If no errors here, if no errors, this whole code converted into binary formats. It is complete all the statements top to bottom binary formats. Binary formats. So next binary formats. All that code converts into binary formats. That code converts into binary formats. Just to convert to binary format. All these code converts into binary formats. All this code converts into binary formats. And type to another file. Yeah, this file is called as exe file, executable file. Yes, executable file means it's a system understandable language. Executable file. So executable file, right? That exe file creates shortcut exe, calling as exe. Okay, so compiler checks whole program from top to bottom. If no errors, everything is correct, generating one exe file. After generating exe file, that exe file given to processor, that exe file given to processor, that exe file given to processor. So processor taking that exe file here and generating outputs. That's it. So this whole program at a time execute, not line by line. Interpreter is line by line. But so one exe file generating. So finally generating one exe file. That exe file executing, right? In case of interpreter, there is no second file, right? Directly that Python script executed here. See, test.py. Directly the script executed, no exe file. Directly script means your source code executed directly here. Source code executed directly. Yes, source code executed directly here, no exe file. Yes, if it is C language, let us come to C language. C language, CDM, it's Linux based. Yes, you guys, Linux, even not understanding Linux, don't worry. Our topic is not Linux, C program topic. Okay. Yes, how to run Java application Linux based. I'll take separate class on this. See Linux and Linux Eclipse install. Eclipse, Java Eclipse. Okay, I'll explain Linux also. Not on Windows based and Linux based also. I'll explain. Yes, now here. SLS, yes, already C program is 1 second. Start dot code dot for remote RM P star remote ls RM. Okay, all the files remote. No files. Present working directory, some MNR directory is nothing, empty, nothing is there. Now I'm writing C program. Gerrit test.c program. Test.c program. Like a Python. Yes. Addition, subtraction, multiplication like this. Same. Yes, C program. Hash includes stdio.h. Hash include stdio.h. Next, white main function starting, ending. Okay. Yes. Int a is equal to 10. Int b is equal to 20. Okay. Next, int c. Yes. C equal to yes a plus b. Next, printf. Yes, printf. Yes, addition value. Yes, addition value is equal to personality slash n comma yes c, displaying c value, addition value after addition. Next, subtraction, next multiplication. Okay, C equal to A plus B, next A minus B, C equal to A into B, A into B, A into B. So addition, next subtraction, subtraction, addition, subtraction. So next multiplication, next multiplication, next multiplication, yes, multiplication. Okay, multiplication, addition, yes, subtraction, and then multiplication. Okay, like a Python script, here C program. Let us try this. See here, test.c, like a test.py, test.c. Now this one we have to compile. GCC is a compile. GCC hyphen c test.c. Compile, no error, no error. Test.o file generated. Now this one should be converted into exe file. CC GCC hyphen o. Yes, yes, exe result in project exe. So exe means some project exe. Yes, this name can be anyone. Test.o. Okay. Now test.c now converting into finally exe file. Test.c compiles. If no compilation error, generating one object file, test.o file. Now that object file is converted into exe format. Okay, exe format. Yes, let's see this. Project is exe file. Finally, project exe file created. Project exe file created. Now this file executing project exe file. Project exe file. Project exe file. See this output. Addition, subtraction, multiplication, got it. Addition, subtraction, multiplication, that's it here. The project exe file. So what's happened? It's exe file. It's exe file. Okay, 1 second. Project. Yes. Executable file. Linux is a file command to check the type of the file. It's an executable file. That exe file contains what binary code. Yes, even you can see gedit project exe file. Open that. Gedit is like a notepad, like a Windows notepad. It's like a Windows notepad. Gedit. Gedit is like a Windows notepad, like a Windows notepad. Okay. Yeah, see this. That exe file. That exe file. 1 second. No. No. Okay. Yes, speaking. Which one? Of course. Yeah, you ask this in online team. Your good name, please. Yes. Yeah, I'll talk to them. Don't worry. Okay. Yeah. Yes, it's a machine language. This is binary code. It's a system understandable language. It's a system understandable language. Okay. So this exe file. So what's happened here? Checking for all errors. If no errors, everything is fine. Yes, generating one exe file executed. That's it. Okay. So this is exe file generated, that exe file executed. Suppose some mistakes. 1 second. Let me remove that file here. Yes, remove file. Remove test.c. Gedit. Yes, test.c file. Suppose let us make some mistakes. Suppose semicolon are missing here. Suppose here some plus missing. Suppose here double quotation missing. Okay, suppose here comma missing. Suppose here bracket missing. Save. Control S, save it. Save it. After saving, now compile it. Yes, GCC, see this, compile it. See, first working directory amend is only test.c file is test.c file is here. Let us compile it. GCC-c test.c. See this. Compile all the errors from top to bottom. Compile shows all the errors from top to bottom. See, 10th line error, 12th line error, next 14th line error. Yes, next. Yes, 25th line error. All the errors from top to bottom. Compile checking all the statement shows all the errors. Yes, compile checking from top. Yes, suppose interpreter first error comes to be stopping. Only 10th line error. If you won't go to the 12th line, next line is here. Stopping there only. Interpreter, any error comes simply stops. Interpreter, any error comes simply stops. But compile is not like that. Compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. All the errors. And shows all the errors. Now, let us correct all the errors. Yes, correction of these errors here. Suppose here, comma. Okay. Next here, brackets. Correction. Save. Still some more errors are there. Correction. Some errors were corrected. Some errors corrected. After correction, series still some more errors. Still getting errors. Okay. Still getting errors. Only test.c file. Not it compiled. Okay. Yes. Now next errors. Suppose semicolon here missing semicolon. That's semicolon. Next here double quotation missing. Save. Save. Yes. Save. After save. No recompile it here. Recompile. Yes. Compile. Yes. No error. The test.2 file created. Now this one convert into exe file. So gcc hyphen o yes project exe file. Project exe file here. Yes, it test.2. Yes, generated. The exe file generated. Project exe file generated. Dot slash projects. Dot/project. See that. That's it. So what's happening here? How compiler working here? From top to bottom. Compiler checks the whole program. Compiler checks whole program from top to bottom. Yes, if no errors. Yes, suppose in here it shows all the errors. It shows all. Compiler shows all the errors. If no errors, then converting this whole code into binary format and write to another file. This file called as exe file, generating exe file. That exe file passing to processor. So processor taking that exe file, executing, finally generating output here. So this is working of compiler. Interpreter compiler difference is that. Okay, let me explain one by one, step by step, points wise. I'll explain it here. Points wise. Let us see points wise. Points wise. Okay. Yes, interpreter. Interpreter. Next compiler. Interpreter and compiler. Interpreter and compiler. How interpreter and compiler is working here? Interpreter and compiler. See interpreter. Interpreter. Yes. Checks line by line. First line, next line like this. Interpreter checks line by line. What compiler whole program from top to bottom. It checks whole program from top to bottom. From top to bottom. Yes, interpreter only one line checks. Interpreter checking only one line. If correct, immediately execution. Next statement, only one statement. But compile is from top to bottom. Yes, whole program from top to bottom. Okay. So first difference. Next interpreter, yes, it generates output. It generates output line by line. It generates output line by line. Yes, compiler at a time output because exe file. Right? Interpreter creating one exe file. Interpreter creating one exe file. So at a time output. That exe file executing and giving at a time, right? At a time output. Okay. Next interpreter, it shows only one error. Any error comes, only one here. Stops there and here. It shows only one error. Interpreter, it shows only one error. It shows only one error. Interpreter shows only one error. Yes, any error comes, interpreter stops. Any error comes, interpreter stops. Means it shows only one error. Okay. Compiler. Yes, it shows all the errors. It shows all the errors. Compiler shows. Interpreter shows only one error. Yes, compiler shows all the errors. Correct? Yes. Next here, main difference between interpreter and compiler, exe file, right? Main difference between interpreter and compiler, it's exe file. Yes, interpreter, it generates exe file. Compiler, no, it won't generate, does not generate exe file. Sorry, reverse I'm explaining. It does not generate exe file. Yes, main difference between interpreter and compiler. Interpreter does not generate exe file. Yes, in case of Python scripting, Directly script executed that no exe file. But in case of compiler, what happened here? That project exe file generated, exe file executed. Okay, so it generates exe file. So compiler it generates exe file, generates exe file. So this is the main difference. Interpreter and compiler main difference exe file. Interpreter and compiler main difference is here. It's exe file. It's exe file. Okay, so interpreter does not generate exe file. Okay, see that interpreter based line Python. Yes, no exe file directly executed. Program executed directly here. But compare what's happened, some exe file generated. That result exe file executed. Okay, so here interpreter does not generate exe file. Next compiler generates exe file. Compiler generates exe file. Compiler generates exe file. Yes, next here. Yes, interpreter based it executes source code directly. It executes source code directly. But compiler it executes exe file. It executes exe file. So interpreter based language directly source code executes. My Python scripting, yes, here Python scripting execute directly, right? Similar Linux shell scripting is there. In Linux, some shell scripts, some test script, test.sh, greach test.sh. It's a script. Test.sh script. Test.sh script is a script. Linux shell scripting. Yes, no error seeking, nothing. Directly executing script like a Python script here. Like Linux script also executing directly. Bash. Bash is a interpreter. Linux interpreter. Okay. Yes, 10. Yes, 20. Choice 1 for addition. See this 30, right? Yes, next I'm executing directly here. First number 20, second number 30. Yes, suppose third option multiplication. Yes, it's a 600 like this. The script executes directly, no error seeking, no compilation, nothing here. Directly executed. Script executes directly here. So interpreter based like it executes source code directly. That code, whatever the code we are writing, that code is source code. Source code executes directly, but here exe file executes. Exe file executes. That's the difference. Okay. Yes, interpreter based language examples. Best example Python. Python is interpreter based language. Next, Linux shell scripting is interpreter based language. Shells Python scripting, shell scripting. Next, HTML scripting. Yes, HTML. See, in case of HTML, see, let HTML example here. Suppose admin Java, here this HTML code. Some HTML file is there. Yes, open with Notepad. See this. This is some login form, user ID, username and password. Username and password. So this is script, HTML script. Double click and run it. Directly opening here. Yes, no error seeking, nothing. Directly executing. See username, password, right? Username, password. So directly executed here. Login form. Directly executed without checking errors. So here this are interpreter based. Yes, browser. HTML is a browser understandable language. Here browser is the interpreter. For HTML, browser is an interpreter. Browser is a interpreter. For example, Google Chrome, it's a browser. That browser is interpreter. Okay, Google Chrome browser, it's an interpreter. It's a browser is the interpreter. HTML is a browser understandable language. HTML is a browser understandable language. Okay, browser is the interpreter for it. So that executes directly here. So HTML, next PHP scripting, yes. Next Perl scripting here. These all are interpreter based language. Yes, compiler based examples. C language. Yes, C++. Next .NET. The examples of compiler based. Okay, right? Yes. See here, interpreter based language. These all are called scripting language. These all are scripting language. They are scripting language. They are scripting. All scripting language. They are scripting language. They are scripting language. These are programming language. Programming language. Yes, programming language. Programming language. See here, scripting language means that can be modified anytime here. Yes, script anytime can be modified. Yeah, that may be subjected to change in future. Script anytime can be modified here. Programming language, programming once application built, we cannot change. Yes, programming once application is built, we can't change it. But scripting language, even application build, we can open, you can modify it. So it can be changed anytime. It can be changed in a script, can be changed anytime. Script means it can be modified. Script can be modified like English. That English can be modified anything here. But programming cannot be modified. You can't. Once build is created, that cannot be changed here. Script can be modified anytime. Anytime. That's it. Okay. So this is difference between interpreter and compiler. See in interpreter, in case of interpreter here, see any interpreter based language, any interpreter based language, any interpreter based language, any interpreter based language, any interpreter based language don't have exe file. That's it. Yes, any interpreter based language don't have exe file. See here, Python scripting, shell scripting, HTML, PHP, Perl, these are interpreter based languages. In this language, no exe file concept. Don't have exe file concept. So any language which is interpreter based, okay, any language. So any interpreter based language, don't have exe file. But in case of compiler based, here everything is exe file. Here everything is exe file. So getting exe file, then everything is exe file. Everything is an exe file. Everything is an exe file. That's it. So this is difference between interpreter and compiler. Yes, next, what is Java? What is Java? Yes, is it compiler based or interpreter based? See here, you guys may be doubt. Yes, actually our course is Java. Our course is Java. But here I'm not touched anywhere Java, right? So interpreter based these things, compiler based example these things. But Java nowhere given example. Java comes under what? What is Java? Yes, what is Java? See, Java depends on both interpreter and compiler. Interpreter and compiler. Reason next class will discuss. Yes, Java. How Java depending on both interpreter and compiler. After that, next we'll say about independent platform. Yes, so this is the introduction completed. So that introduction is over. So requirements were to understand independent platform, the prerequisite completed. Today complete all the prerequisites to understand Java features. Okay. So next, Java depending on interpreter and compare, how here the topic we'll discuss next class. Okay. See, this is today topic. All this today topic very clearly prepared. Document software, application software, SOS. Yes, next. Yes, front and back end language and package, language, low level language, high level languages. Yes, this generation of language next class will discuss. Next, difference between interpreter and compiler. Very clearly explained here. All the points. All the points. All the points side by side explained very clearly. Okay. Java depends on both interpreter and compiler. Yes, this topic. Yes, will take minimum half an hour to explain this. Half an hour I need. Today I can't finish, already 6:30 time. So next class we'll discuss about this one. Next we'll go to Java features. Next class we'll go to Java features. Okay. Yeah. That's all for today. Yes, any doubts? Yes, guys, any doubts? Hello. Any doubts? Yeah. So tomorrow we'll continue class. Tomorrow we'll continue. Right? That's all for today. Tomorrow we'll continue. Yes, the Java features. Okay, tomorrow we'll continue for Java features. Yeah, that's all for today. Tomorrow I'll take Java features. Thank you guys. Yes. See you tomorrow.